Today, we are going to start with carbohydrate chemistry. So, first, entire carbohydrate is being divided into 5 lectures. In the first lecture, we are going to deal primarily with the structure, features, properties, reactions, and also the various tests which are performed for carbohydrates. In the subsequent lectures, we come to the metabolism part of carbohydrates in our body. So what is a carbohydrate? Carbohydrate is a polyhydroxyaldehyde or a ketone molecule having formula CnH2O whole N. Here, the carbon and water molecules are present in the same ratio in most of the carbohydrates. So here, this is an example. Glucose is an example of a polyhydroxyaldehyde because it has got an aldehyde group, as you can see at the top. And similarly, fructose, the best example of polyhydroxyketone, where we have the ketone group present. Some of the importance of carbohydrate. Most abundant dietary source, and it is one of the most important material or a source which is required by brains and RBC. These two parts of our body are entirely dependent on the carbohydrate for their energy because they can't take energy from fat or proteins. It also acts as a storage form of energy, which is glycogen in our body or in humans, whereas it is a starch in the case of plants. Carbohydrates are also precursors for many organic materials like fats and amino acids. We will come to know subsequently that fatty acid can be synthesized from acetyl-CoA, which is a precursor molecule of the TCA cycle, which is generated by several steps of the glycolysis procedure. It also plays a certain role in the cell membrane and cell functioning, cell growth, adhesion, and also fertilization. The carbohydrate molecules in certain cases acts as receptor molecules because they are glycoprotein molecules which act for receptor for various hormones or various other enzymes. And it also participates in cell signaling because in several cases we will come to see subsequently that this carbohydrate molecules also plays a role in cell signaling. Certain carbohydrates are used as drugs like cardiac glycosides, which is digoxin, which is a commonly used cardiac drug, whereas we have certain antibiotics like streptomycin, which are also being used. Coming to the sources, as we are very familiarized with these, we know rice, wheat are the most common source of carbohydrate which we in Indian diet consume. Classifications of carbohydrate, starting from monosaccharide, oligosaccharide, polysaccharide. What is a monosaccharide? Monosaccharide is a carbohydrate molecule which cannot be further hydrolyzed or which cannot be broken down into smaller pieces. Examples of carbohydrate molecules with 3 carbon is triose, which includes glyceraldehyde dihydroxyacetone. With 4 carbon atoms is tetrose, erythrose, erythrulose. With 5 carbon atom is pentose. Examples are ribose, xylose, ribulose, and xylulose. Hexose is 6 carbon compound and having glucose, galactose, and fructose. And heptose is 7 carbon compound and have glucoheptose, steatoheptulose. Now, coming to the D-glyceraldehyde and L-glyceraldehyde. These are the two different forms of the glyceraldehyde molecule. Now, coming to oligosaccharides. What is oligosaccharide? Oligosaccharide is a group or a chain of monosaccharides between 2 to 10 monosaccharide molecules, each joined by a glycosidic bond. It can be disaccharide, trisaccharide, tetrasaccharide, or pentasaccharide. Disaccharide includes maltose, lactose, sucrose. Trisaccharides includes raffinose, tetrasaccharides, stachyose, and pentasaccharide is verbascose. Polysaccharide, any carbohydrate molecule which are made up of more than 10 carbohydrate or 10 monosaccharide unit is known as a polysaccharide. It can be classified into two, Homo Polysaccharide and heteropolysaccharide. Homo Polysaccharides includes starch, glycogen, cellulose, inulin, dextrins, and chitin. whereas heteropolysaccharides includes agar and mutropolysaccharides. Isomer. What are isomers? Isomers are chemical structures or are compounds which have the same formula but differs in their structure. Example is glucose and fructose, both having the same structure chemical formula, which is C6H12O6, but one is an aldose where other is a ketose. Coming to stereoisomers. Stereoisomers are compounds which have the same chemical and structural formula but differs in their spatial configuration or their arrangement. Here we are concerned with the mode electronegative group. Here OH is a mode electronegative group. So depending on the position of the OH group, we are going to name it as D or the L form. So here we have the D form and the L form. If D, its general trend, if D is towards the right, we call it a D-glyceraldehyde, and if OH group is towards the left, we call it as L-glyceraldehyde. This D and L configuration of a stereoisomer is generally dependent upon the penultimate carbon atom. Penultimate carbon atom is the reference carbon atom. It is the carbon atom which is the farthest from the CHO group. So here, this last CH2OH is the penultimate carbon atom. So this will be deciding the chemical structure or the D or the L form. Coming to the subsequent part, we have this. What is an asymmetric carbon atom? Asymmetric carbon atom means that the 4 different groups are attached to the same carbon atom. This is also called the chiral carbon. This is called the chiral carbon. The number of possible stereoisomers depends upon the number of asymmetric carbon atom present in the molecule, and that the total number of stereoisomers which can be present is actually 2 to the power n, where n is the number of asymmetric carbon atoms. Now coming to the reference carbon atom of sugar. All monosaccharides can be considered as a molecule derived from glyceraldehyde by successive addition of carbon atoms. Therefore, penultimate carbon atom is the reference carbon atom for mirror imaging or for the D and L isomer, capital D, capital L isomerism. D and L isomerism as enantiomers. So, these D sugars are naturally occurring sugars in the body and can be metabolized only D sugars. D-glucose is dextrorotatory. In clinical practice, it is called as dextrose. Now coming to optical isomerism. We have to remember that capital DL configuration is different from the small d, small l configuration. This small d, the capital D, capital L configuration mostly occurs depending on the penultimate carbon atom and their chirality, whereas the optical isomerism occurs due to the ability to rotate the optical light or plane polarized light in certain direction. The presence of asymmetric carbon atom causes this optical activity. When a beam of plane polarized light is passed through the solution of carbohydrate, it will rotate the light either to the right or to the left. If it rotates the light towards the right, it is called the dextrorotatory, and if it rotates the light towards the left, it is called the levorotatory. We know that D-glucose is dextrorotatory, but we have to remember that D-fructose is levorotatory. Equimolar mixture of this equal amount of D and L form together has got no net rotation and is known as the racemic mixture. Next, what is an epimer? When sugars are different from one another only in configuration with regard to a single carbon atom other than the reference carbon atom, they are called epimers. Here, this is the structure of glucose. CHHOHOHH, HOHHOH, CH2OH. If this OH, which is present towards the right in the case of glucose, goes towards the left, the entire compound changes and we get D-mannose having OH towards the left. This is a C2 epimer. So mannose is a C2 epimer of glucose. Similarly, from glucose, if in the C4 position we change the OH position from right to the left, we get a completely different compound, which is D-galactose. So, which is a C4 epimer. So, C1 or C2 epimer and C4 epimer. So, mannose is a C2 epimer, whereas galactose is a C4 epimer of glucose. Coming to anomer. What is anomer? We have to first, before we go into anomerism, we have to know the three structures of glucose. This is the general structure of glucose, which we are very familiar with, the open chain form. This is the Fisher's formula. And this is the Hawad's formula or the pyranose structure of glucose. So this is the structure which is alpha D glucopyranose, and this is a structure. This is an alpha D glucopyranose structure, and this is an alpha D glucofuranose structure. This is having a hexacyclic ring. It is having a pentacyclic ring. This is a pyran structure, and this is a furan structure. The first carbon atom aldehyde group is condensed with a hydroxyl group of the fifth carbon atom to form a ring. Ring structure represents the hemiacetal form. Glucose exists in biological system not as a rectangle but as a pyranose ring mostly. Beta D-glucopyranose is the predominant form. D-glucose has two anomers, alpha and beta variety. These anomers are produced with spatial configuration with reference to the first carbon atom in aldose and second carbon atom in ketoses. These carbon atoms are the anomeric carbon atoms. This is a structure of the alpha D glucose, and this is a structure of the beta D glucose. We know that the beta D form of glucose is more preferable or more stabler than the alpha form. But this is the one, this is the anomeric carbon atom. This is the alpha form or the alpha D glucopyranose, and this is the beta D glucopyranose. The beta form of glucopyranose ring is more stabler than the alpha form. This is due to the presence of alpha 1,3 diaxial interactions, which is taking place in the case of alpha form, which is a kind of steric hindrance which is seen. So the beta form is preferred. What is mutarotation? Mutarotation, when D-glucose is crystallized, at room temperature and in a fresh solution is taken, it is seen that the rotation of the polarized light is about 112 degrees. But it is seen that after 12 to 18 hours, it changes to 52.5 degrees. This change in rotation with time is called the mutarotation. This occurs due to the change in this alpha and beta form which is taking place. This change in the alpha and beta form is taking place. That's the reason the change between the alpha and beta form, or there is a change in their conformation. Alpha D glucopyranose has a structure which has a rotation of about 112 degrees, whereas beta D glucopyranose has a rotation of about 19 degrees. 1/3 of the molecules are alpha and 2/3 molecules are present in the beta variety. And just at a normal level, we see that the specific rotation comes in somewhere in between the two, that is 52.5 degrees. Now, so here we have the entire thing. When either alpha form or beta form of glucose is dissolved in water, optical rotation changes and eventually a value of plus 52.5, 52.6 degrees obtained. Thus, the alpha form changes to beta form and eventually a solution of 36% alpha form, 64% beta form is obtained. This phenomenon is known as the Mutarotation. Coming to the disaccharides, we have sucrose, maltose, isomaltose, and lactoses. Sucrose, we know it is a common sugar which we take. It's an example of sucrose, which is cane sugar. It's present in sugar cane in various forms. This is the structure of the sucrose molecule. And here we have, it is actually the chemical compound is having a glucose and a fructose molecule joined together by a glycosidic bond. So the molecule is also known as the alpha D glycosyl beta D fructoside. Hydrolysis of sucrose will produce one molecule of glucose and one molecule of fructose. The enzymes which dissolves sugar molecule or sucrose molecule is nothing but sucrase or invertase. Honey contains invert sugar. Invert sugar is sweeter than sucrose. Coming to lactose. Lactose, we know that it's primarily present in milk, and it is made up of a glucose and a galactose molecule, two molecules joined by galactose or beta-1,4 glycoside linkages. So this is the structure of galactose molecule, where we have a beta-1,4 glycoside bond. But we know that most people nowadays are seen to have lactose intolerance. This is due to the absence of the enzyme lactase. Due to the absence of the lactase enzyme, when this milk enters the intestine, the bacteria, or which is the normal flora of the gut, they act upon the lactose and ferment the lactose molecule, thereby forming large amount of acids and also gas. This leads to flatulence and also bloating, and also in certain cases diarrhea. Maltose. What is maltose? Maltose is basically two molecules of glucose joined by a alpha-1,4 glycoside linkages. Coming to isomaltose, two glucose residue which are joined together by alpha-1,6 glycoside linkages. Coming to reactions of carbohydrate. First, the most important reaction which we consider is the Benedict's test. What is the Benedict's test? It is mostly performed to see or check for sugar molecules in urine samples. Here, first we come to know this enediol, which we were talking about, that glucose, if we need to convert glucose to fructose, it has to go through an intermediate form, which is an enediol rearrangement step. So this is 1,2-enediol, which is an intermediate which is formed when we convert glucose to fructose. So sugar. Acha. Now, this Benedict's test can only be performed in only when there is certain amount of alkaline condition is prevailing. So the Benedict's test, sugar is first converted to enediol, then it is oxidized to sugar acids, and subsequently copper sulfate is reduced because it is an oxidation reduction reaction. Copper ion is Cu2 plus is getting converted to Cu, leading to CuOH2 and Cu2O, giving a red coloration. So here we require a alkaline medium or an alkaline condition for the entire test to be performed. The principles of Benedict's test is that when reducing sugars are heated in presence of alkali pH 10.6, they get converted to powerful reducing compounds known as enediol. Enediol reduces the cupric ion Cu2 plus in presence of Benedict's reagent, cuprous ion, and gets precipitated as insoluble red copper oxide. So this is what it looks like when we have the test done. Then it is mostly used, as I already told, that it is mostly used for the detection of glucose in urine samples. It is a standard laboratory test which is employed for the follow-up of diabetes in PHC patients. Benedict's reagent contain sodium carbonate, copper sulfate, and sodium citrate. Contains sodium carbonate, copper sulfate, and sodium citrate. Any sugar with free aldehyde or keto group will reduce the Benedict's reagent. Any sugar with free aldehyde or ketone group will reduce the Benedict's reagent. Therefore, this is not very specific. Carbohydrate giving positive Benedict's test is glucose, fructose, lactose, maltose. Starches do not react or react very poorly with Benedict's reagent because it has a relatively small number of reducing sugars. Non-carbohydrate giving the Benedict's test are high concentration of uric acid and ketones, homogentic acid, are vitamin C, and certain drugs like aspirin and cephalosporin are some which are not carbohydrate molecules but gives positive Benedict's test. Glucose oxidase test. Glucose on reaction with oxygen in presence of glucose oxidase gives gluconolactone plus H2O2, which is peroxide. H2O2, which is further reduced to give peroxidase. We use the enzyme peroxidase and it gives an oxidized color dye. Reagents for this test are present in strips of paper. So because of this, glucose oxidase enzyme acts only on beta D glucose. Other reducing substances do not give this test positive. Thus, the compound like vitamin C, aspirin utilizes H2O2 produced in the reaction. Due to the lack of H2O2, peroxidase cannot oxidize the dye, giving a false positive test. Thus, glucose may not be detected even if present if the urine contains vitamin C, giving a false positive test. Coming to the ozazone formation. All reducing sugars will form ozazone with excess of phenylhydrazine when kept at a boiling temperature. So this glucose, lactose, fructose will produce the same needle-shaped crystal. So here we see that the D-glucose molecule which reacts with phenylhydrazine to form an ozazone. So here glucose and mannose, two being epimers, give the same ozazone. Maltose test. All carbohydrates when treated with concentrated sulfuric acid undergo dehydration to give furfural compounds. These compounds condenses with alpha naphthol to form colored compound. Maltose test is given by sugars with at least 5 carbon because it involves furfural derivatives, which are the 5 carbon compounds. So this is a purple ring which is seen in the case of Maltose test. Coming to Felling's test, it is a test for reducing sugars. So this consists of two Fellings. Fellings A contains 7% copper sulfate and Fellings B contain sodium potassium tartarate. So the principle is it only helps in the detection of reducing sugars. Coming to the Barfoed's reagent or Barfoed's test. The test is based on the same principle as Benedict's test, but the test sample is acidic, whereas in the case of Benedict's we had a pH of about 10.6, which was a basic pH. In acidic pH, pH 4.6, monosaccharides react faster than the disaccharide molecules. Barfoed's reagent contains copper acetate in glacial acetic acid. Barfoed's reagent consists of copper acetate in glacial acetic acid and giving a scanty red precipitate in the bottom of the test tube. Coming to the Sullivan-Off test. Sullivan-Off test is a chemical test which distinguishes between aldose and ketose. Ketohexose like fructose on treatment with HCl gives 5-hydroxymethyl furfural, which on condensation with resorcinol gives a cherry red complex. This is the reaction where we are getting the hydroxymethyl furfural, where we react with resorcinol, we have a condensation product which is red in coloration. Oxidation. Now, the gluconic acid, gluturic acid, and also we have the glucosaccharide acid or gluturic acid, gluconic acid, and glutaric acid or glutasaccharide acid. The gluturic acid is used by the body for conjugation with insoluble molecules to make them soluble in water for detoxification purpose, for various detoxification purpose. Now, what is this which we are concentrating on? If glucose molecule having a CHO group at the top and CH2OH group at the bottom reacts with mild oxidizing agent like hypobromous acid, bromine in water, the aldehyde group is oxidized to carboxyl group to produce what is known as the aldonic acid, which is a gluconic acid. When the glucose molecule is reacted upon by strong oxidizing agents, Like nitric acid, both the compound, both the CHO and the COOH group gets CHO and the CH2OH group both gets converted to COOH, thus leading to the formation of the glutarate acid. And if we use something like the mild oxidizing agents, we will form glucuronic acid, where only the CH2OH group gets converted to COOH. Next, reduction of alcohol. When treated with reducing agent, hydrogen can reduce sugars. Aldose yields corresponding alcohol. Glucose is reduced to sorbitol. Sorbitol is a major cause. Sorbitol is a major cause of the formation of cataract in eyes. Fructose becomes sorbitol and mannitol, and galactose is reduced to dalkitol and ribose to ribitol. Significance of reduction: sorbitol, mannitol, dalkitol are used to identify bacterial colonies. Mannitol is used to reduce intracranial tension by forced diuresis, and the osmotic effect of sorbitol produces changes in the tissues when they accumulate in abnormal amount. Example, cataract. So these are the reactions which are taking place. Osmotic laxative, we use lactulose, which is a commonly used osmotic laxative which is being used commercially for treatment. Lactulose. Lactulose, also known as beta-D-galactopyranosyl D-fructofuranose, used for constipation purposes. The structure. Coming to glycosides. The hydroxyl group of anomeric carbon of a carbohydrate can join with the carboxyl group of another carbohydrate or some other compound to form glycoside, and the bond is known as the glycosidic bond. The non-carbohydrate moiety is known as the add-glycone, which is a phenol, sterol, glycerol, and methanol. Glycosidic bond can be N-linked or O-linked. Here we have methyl alpha D glucopyranoside and we have methyl beta D glucopyranoside. Importance of glycoside: cardiac glycosides, which are commonly used, are digoxin, digitoxin, used in cardiac insufficiency, stimulates the cardiac muscle contraction, contains steroids and add-glycone components. Aubane is a sodium-potassium pump inhibitor. Streptomycin is one of the antibiotics which is used in tuberculosis, why only tuberculosis, and several other diseases, and it's also majorly made up of carbohydrate moiety, and it's basically a glycoside. Then we have fluorazine, which causes the renal damage of leukocyuria, blocks the transport of sugar across the mucosal cells of the small intestine and also renal tubular epithelium. Formation of esters. Esterification of alcohol group of monosaccharides with phosphoric acid is a common reaction in metabolism. Glucose 6-phosphate and glucose 1-phosphate are examples where ATP donates the glucose moiety. These reactions are very common reactions. The glucose 6-phosphate is formed from glucose as a first step of the glycolysis procedure, where we use hexokinase or glucokinase. Amino sugars. Amino sugars may be substituted by amino group may be substituted for hydroxyl group of sugar to give rise to amino sugars. Importance of amino sugars: we have glucosamine, galactosamine, monosamine, and N-acetyl glucosamine, N-acetyl galactosamine. The glucosamine is present in hyaluronic acid, heparin, and blood group substances. Galactosamine is chondroitin sulfate of cartilaginous bones. Monosamine, constituent of glycoprotein, and we have N-acetyl galactosamine present in the cell wall of bacteria. Deoxysugars. Oxygen for hydroxyl group may be removed to form a deoxysugar. So these deoxysugars are one of the most important example of deoxysugar is the deoxyribose, which is seen in the case of DNA, deoxyribonucleic acid. Coming to homopolysaccharides. What are homopolysaccharides? Are the carbohydrate molecules which are made up of a chain of a single monosaccharide unit. Starch. Starch is a reserve carbohydrate in the plant, and its sources are potatoes, cereals, and other food grains. Starch is composed of amylose and amylopectin. So amylose and amylopectin, these are the two structures. Amylose having alpha-1,4 lipocydic linkage only, whereas the amylopectin having alpha-1,6 lipocydic linkage. The amylose having a shorter structure and they are not branched, whereas amylopectins are branched structure. Amylose is made up of glucose units with alpha-1,4 lipocydic linkages forming unbranched long chain, water soluble. Insoluble part is not soluble in water and is made up of amylopectin. Amylopectin is also made up of glucose unit but is highly branched and have alpha-1,6 lipocydic linkages. The iodine test, the starch on reaction with iodine gives a blue colored or a bluish black coloration. This is a test for the iodine, for starch, presence of starch. Hydrolyzed of starch, amylodextrin, violet color with iodine and is non-reducing. Then on waiting for a certain amount of time, it gives erythrodextrin, which gives a red color, then gives artodextrin, which has no color, and then we have maltose, no color with iodine, but powerfully reducing. So the initial coloration, which we say as bluish black or violet coloration, is due to the presence of amylodextrin. On waiting for a longer period of time, we will finally get maltose, which is having no coloration with iodine. Coming to glycogen. Glycogen, it is a reserve carbohydrate form in the livers and muscles, and it is a storage form in humans. Liver glycogen store increases during the well-fed state and are depleted during the fasting process. Glycogen is composed having both alpha-1,4 and alpha-1,6 lipocydic linkages, and we have certain things called certain places where we have the alpha-1,6 linkages is called the branching points. Glycogen is more branched and more compact than the amylopectin. So this is the entire thing of liver and muscle glycogen. Glycogen can be broken down into glucose 6-phosphate and finally to glucose in the liver by the process which is known as the glycogenolysis, which takes place in the liver cells. Cellulose. Cellulose is a major form which is present in the leaves and vegetables. It is made up of beta-1,4 lipocydic linkage. It has a straight line structure with no branch point. The beta-1,4 bridges are hydrolyzed by enzyme cellulobiase. This enzyme, we humans, we do not have the enzyme cellulobiase to dissolve or cellulase to digest cellulose. So, this enzyme is present in the intestine or in the stomach of the goat, cow, which can digest grasses, but we humans do not have the enzyme to digest cellulose. So actually we don't have any mechanism to digest the cellulose, and so it goes undigested into the fecal matter. Importance of cellulose is a major constituent of fiber and non-digestible carbohydrate. We must keep in mind oats which we consume for reducing weight or doctors prescribe for reducing weight is primarily cellulose. So the entire meal of oats gives you a feeling of heaviness or a completeness, but ultimately the body cannot use a single part and it goes entirely to your fecal matter undigested. So this is a way of giving a feeling of fullness to your stomach. Importance of cellulose, it is a major constituent of fat. Fibers can absorb 10 to 15 times of water and therefore help in the process or decrease the risk for constipation. It can also have a property to decrease chances of certain cancers and also delay gastric emptying and can result in sensation of fullness, just like I told you. Inulin, it is a long chain homoglycan composed of D-fructose unit with repeating beta-1,2 linkages. It reserves carbohydrate present in various bulbs and tubers such as onion and garlic. It is clinically used for performing the renal function test because it goes unfiltered or it cannot be absorbed single bit by the kidney. So it goes unabsorbed through the kidney and therefore it's important for the detection of the renal function. Coming to dextran, they are highly branched homopolymer of glucose unit with 1,4, 1,3 and 1,6 linkages. They are produced by microorganisms. They are used for the treatment of the hypovolemic shock. Since they will not easily go out of the vascular compartment, they are used as intravenous infusions. Dextrose, dextrine, and dextran. What is dextrose? What is dextrine and dextran? And they are not the same thing. D-glucose is known as dextrose in medicine, bedside medicine. Dextrine is a partially digested product of starch, and dextran is a high molecular weight carbohydrate produced by bacteria, which is being commonly used in hypovolemic shock when the amount of blood in your body decreases. If body enters a state of shock known as the hypovolemic shock, when the volume of blood inside the body decreases to a substantial level. Coming to tritine, tritine is the most common heteropolysaccharide present in the exoskeleton of insects, composed of N-acetylglucosamine and which are having beta-1,4 glycosidic linkages. And then we have heteropolysaccharides, agar and mucopolysaccharides. Agar is a very important thing which we are using in microbiology laboratories for the growth of the culture bacteria. So agar, the linear polysaccharide agarose plus agaropectin, it is dissolved in water at 100 degrees Celsius, which upon cooling sets as a gel and can be used as agarose gel, which is used in electrophoresis procedure. Agar cannot be digested by bacteria and hence used widely as a media for growth. Mucopolysaccharide, example is glycosaminoglycan. We have an acidic sugar and an acetylated amino sugar which are joined together forming a mucopolysaccharide. Glycosaminoglycan are present in all the tissues of our body which contain which is present in the matrix. Because of their large number of negative charge, these heteropolysaccharide chain tends to be extended in solution. They repel each other and are surrounded by a shell of water molecules. When brought together, they slip past each other. This produces the slippery consistency of synovial fluid and mucus secretion. This is due to mostly the mucopolysaccharides. The property contributes to the resilience of the synovial fluid and the vitreous humor of the eye. So this is applied glucosamine, glutyronic acid, and L-ioduronic acid. Hyaluronic acid is a kind of liposaminoglycan, which is made up of D-glucuronic acid and N-acetyl D-glucosamine present in the synovial fluid, and its function as a shock absorber. Then we have chondroitin sulfate, which has D-glucuronic acid and N-acetyl D-lactosamine 4-sulfate, and it's present in the bones, cartilage, tendons, helps in maintain the structure and shape of the tissues. Then we have dermatan sulfate, which has D-ioduronic acid and N-acetyl D-lactosamine present in the skin, helps to maintain the shape. We have keratan sulfate, which has the lactose and N-acetyl glucosamine and present in cornea and in tendons and keep the cornea transparent. We have heparin, which is using as an anticoagulant. Hyaluronic acid, as we have discussed, these are all the things which we have already discussed, and then we have hyaluronidase, which breaks the hyaluronic acid into subsequent parts. Coming to chondroitin, chondroitin made up of glutyronic acid and has beta-1,3-N-acetyl galactosamine sulfate and beta-1,4 and so on. Dermatan sulfate, and then we have these are the structures. Then this is the structure for keratan sulfate. This is the only glycosaminoglycan which does not have a uronic acid in it. This is heparin. Heparin is a molecule which is having an anticoagulant property and having an L-ioduronic acid. Heparin is an anticoagulant. Heparin helps in the release of enzymes called lipoprotein lipase, which helps in clearing the turbidity of lipemic plasma. Lipoprotein lipase breaks the triglycerides in glycerol and fatty acids. So this is what we have. Heparin displaces the lipoprotein. Proteoglycans and glycoprotein. Proteoglycans, when carbohydrate chains are attached to a polypeptide chain, is known as the proteoglycan. And when carbohydrate content is less than 10%, it is known as the glycoprotein. So this is the proteoglycan aggregate, and this glycoproteins. We have glycoproteins of erythrocyte cell membrane. We have then we have the collagen, which is the structure of the cartilage. We have ceruloplasmin, immunoglobulin, and intrinsic proteins, intrinsic factors which is required for the absorption of vitamin B12. Glycophorin, which is a glycoprotein of erythrocyte cell membrane. Collagen is made up of hydroxyproline and hydroxylysine and is a primary structure of the cartilage and bones. Immunoglobulins, as we all know, it helps in providing immunity. So thank you. And if you really like the lecture or the video, please like and subscribe in the YouTube channel. Please, it's a request.